This is the bus sensor, tiny, cute, and simple connection. You can buy it on any e-commerce site for just $2. In this video, let's build the heart rate monitor using the bus sensor. Instead of just reading out the body lock like this, let's use the 7-inch LCD to make the app more appealing. To make this video easy to follow, I will divide it into 4 parts. First, let's talk about the hardware. This is where I introduce the hardware we'll be using in this video, like STM32 LCD and the bus sensor. Next is the RAM for communication with the bus sensor, writing in STM32 and STM32 QIDE. Then, we will talk about the user interface design of the application on the TouchGFX. Finally, we will combine the sensor reading the RAM and the interface to produce the final result. Alright, let's get started. First, let's look at the hardware. I will using the bus sensor that is very common on the market today. This simple sensor consists of only 3 pins, VCC, CND, and the signal pin, with an operating voltage range from 3.3 and 5 volts. It is compatible with most microcontrollers currently available. The output signal is analog. You can easily read it using the microcontroller ADC peripheral. This sensor doesn't include the function like the heart rate monitoring, so we have to calculate and style it using code. But just for $2, we cannot expect much more. Regarding about the microcontroller, I will using the STM32 A7 microcontroller. The A is the high performance microcontroller series. It can meet all your requirements. And if you wondering why we need the very high performance microcontroller to read the ADC sensor, the answer is that I need the performance of the STM32 A7 to be able to control the 7-inch LCD. This is 7-inch LCD using LTDC communication, the style of LCD that requires the microcontroller at this frame. Therefore, if you only need to control the smaller LCD such as 2.8 LCD, you will need to use the STM32 A7. About the code, first we will configure the ADC pin on the STM32 QMS. With UI symbol, select the ADC pin you want to use to read the sensor. Here I will select the ADC1 channel 2, configure the necessary parameters such as sampling rate and the frequency divider. At the same time, create an additional stat on filter to read in the sensor. This stat will be named as sensor stat because it simply reads the sensor, so you don't need to allocate too much stat space to it. If you're wondering why we configure so many CBO in the diagram on the right, they all for the LCD. Controlling the LCD LTDC is actually quite complex. Let the generate code custom and you're ready to go. Now wait a moment for the chart to be inboxed into STM32 QIDE. In the STM32 QIDE, we need to read the sensor value from the ADC pin and say it. Reading the ADC value from the STM32 is quite simple because the whole library provides the API to help you do that. To debug the value, let's try to read it out to the serial board. Compiler and upload the program. I'm using the STM32 programmer. Then let's see the serial log. As you can see, it's like the random value, right? Because the ADC signal is very fast, it will be difficult to visualize the value we are reading. A little tip, you can use the refine function on Arduino IDE to try destroying the waveform. See, the signal is easy to visualize now, right? The bit in the wrap in my heart speed, the signal is still noise because we only read the raw value from the ADC, so we need to add more noise filtering steps to get the better result. But don't expect too much from the sensor, just around $2. For the user interface, we will use the TouchGFX. The reason I use it is because it's free software for the STM32 and it has the built-in wrap widget, so I don't have to redesign it from scratch. Let's start designing the interface. First, the interface will have the wrap to display the heart rate. We will not need the X label, so add some text here to display the heart rate and the raw ADC value. And here is another heart shape and some more frame to make the application look better. This is very easy, right? So we basically finished the interface part. List on the generation code button. And now the TouchGFX code has been added to the STM32 QIDE. Okay, now try letting the interface onto the hardware. Because this is just the static interface, We cannot see any change to the interface. I don't think it's very pretty. Maybe I don't have the stylus or spanty. Let's move on the final part, combining sensor reading with the LCD display. With the TouchGFX connecting the sensor reading back, writing in C and the interface design writing in C++ have a bit tricky. We will not be able to directly include the sensor library into the C++ file and use a function to read it as usual. First, it needs to follow the structure of TouchGFX with the MVP or model view and recenter. You can read more about the MVP structure on the TouchGFX homepage. Basically, the model is the latch that communicates with the hardware or handle the logic. The view is the latch responsible for display or the interface design, and the recenter is the latch that connects the model and the view. So now returning to our application. First, we need to create the message queue to pass the data to the model. In the STM32 QMS, create the new message queue with the stand element, each element being the 16-bit size. Then let the generate custom to update the regex. In the sensor reading state, we will check the message queue is empty, and if so, we will send a value to the newer create message queue. In the model test function, we wait for bucket for the message queue and add a packet to send to it, retrieval it and send it to the UI. As mentioned earlier, the TouchGFX uses the MVP structure, so we must send the data to the recenter first, and then from the recenter, we will send the wrap values to the view. In the view layer, we simply add new value to the wrap, and the TouchGFX will connect the parts together, create the visual wrap. Let's try loading it into the hardware. The app seems to work well. When I place my finger on the sensor, the value that has been read and immediately displayed on the wrap. Because it is the chip sensor, so the reading are noise, and you also need to adjust your finger position to get the most stable result. So we have finished the designing the simple heart rate monitor. If you don't have the 7-inch LCD, you can absolutely use the small LCD, no problem. Thank you for watching. See you on the next video.